I'm Julie Richardson. I'm a partner in Reddie Grose's Electrical, Electronic and Software, EES group, and head of our Artificial Intelligence and Internet of Things Technology Focus group. My colleague Chris Smith is a senior associate, also in our EES department. We know that several people attending work with other practice groups in Reddie Grose, chemistry, life sciences and computer products, for example. Some of you work with us in the EES group, and other attendees are from organisations with an investment or consulting role, and academia, for example. Thank you all for listening. We hope you find it beneficial. So, what is artificial intelligence? There are many differing definitions of artificial intelligence. My current favourite, because it's short, is an umbrella term for the science of making machines smart. It's short and tells you what AI is, but it doesn't really tell you where AI is being used. Whereas the UK IPO definition, technologies with the ability to perform tasks that would otherwise require human intelligence, such as visual perception, speech recognition, and language translation, already gives you an idea of where we might be heading with this talk. Artificial intelligence is a branch of computing. In traditional computer programming, a programmer designs a computer program, a set of fixed mathematical operations performed in a specified and unchanging way. By running the program on a computer, input data, processed in accordance with the fixed rules, provides an output. Machine learning is an implementation of artificial intelligence, and it's different from traditional computer programming. In machine learning, you set up a framework which has lots of numerical parameters that can be adjusted to change how the data is processed by a computer. Initially, you don't know what the parameters should be to get the result you want, and so you have to train the system by allowing it to adjust the parameters. At the start of the training phase, the framework usually has random parameters. Over the course of processing large amounts of training data, the computer tweaks the parameters. And at some point, the machine learning AI will have seen enough examples that when we give it an input, it can accurately predict what the output should be. The machine learning AI can then move from the training phase to the prediction phase, in which it performs the task for which it was designed. At the changeover from the training phase to the prediction phase, you can fix the parameters and use the prediction model to make predictions based on new data. Alternatively, you can start to use the prediction model, but allow it to continue to adapt based on the additional data it's processing. The training phase requires large amounts of data because the machine learning AI is learning from statistical correlations in the training data to improve its prediction about what the output should be for a given input. The type of data being processed and the type of result needed affects the sort of statistical correlations that may be present, the arrangement of the network that's best suited to the problem, and which of several different mathematical techniques are best suited to control how the machine learning model adapts the parameters. So for a machine learning AI, there are two distinct phases, the training phase and the prediction phase. How does Google know what to suggest while you're still entering the search term for your internet search? It uses a trained machine learning AI to predict from all the previous searches it knows about and the training data it was fed, the most likely search term based on your partial input. AI is constantly being hyped as the solution to every problem. But from an intellectual property perspective, which sectors are adopting AI? The graph on the slide is taken from a 2019 World Intellectual Property Organization report. It shows a rapid rate of increase in AI-related patent applications since around 2011, broken down by the technology to which the AI is applied. The rate of increase in several areas, for example, telecommunications, transportation, life and medical sciences, and security, which is, for example, detecting fraudulent bank transactions, is more marked than in other sectors, industry and manufacturing and document management and publishing, for example. This is probably attributable to the difficulties in patenting the latter areas generally. More than half of the AI-related applications were filed after 2010. The Intellectual Property Office is well aware of the explosion in the application of AI. 5 patent offices together account for 80% of patents worldwide. These are the IP5, the US, Chinese, Japanese, Korean, and European patent offices. And the IP5 have established a special task force on new and emerging technologies and artificial intelligence in response to this explosion of AI-related patent applications. If we dig a bit more into the sectors identified in the graph, we can get a feel for how AI is being applied. The key application for AI in transportation, of course, is autonomous vehicles, which is always in the media. AI in the form of computer vision is being used for lane keeping, parking applications, recognizing signposts, predicting driver behavior. But autonomous vehicles are also being used in agriculture, and AI is being used in drones. For example, an application I've heard recently is how they should swarm to monitor radioactivity and how they can provide automated images for geological purposes and mapping and agriculture. In the telecoms field, machine learning is being applied in power management of 5G networks. For example, by using key performance indicator data, capacity and coverage of networks can be adjusted by switching cells in the network on and off. And AI can be used to prioritize between mobile and fixed network users in different operating conditions. Earlier this year, a company called PI Works gave a webinar at the UK Institute of Engineering and Technology, the UK equivalent of the IEEE, about their use of machine learning in 5G field, and they're applying for and being granted patents in this area. In life and medical sciences, AI is being used to sift through masses of data and identify which medicines might best be suited to a new use. AI-based computer vision is being exploited to help analyze clinical images and automate identification or prediction of an imminent disease. It's being used with language processing to mine electronic health records, although some of these aspects face more additional hurdles for patenting than others. I've already mentioned that in the security field, financial institutions are using AI to detect banking transactions. Where else would I expect to see AI being exploited? Well, one of the things I thought about preparing was that non-destructive testing, for example, uses images to assess the integrity of welds. I haven't seen any patent applications using AI in this field yet, but I'm sure someone will be thinking about it, and if not already using AI in non-destructive testing. So it might be an area where we'd see applications in the future. Having discussed that there's been an explosion in patent applications being filed around the world, my next sort of consideration is, yes, that's all very well and good, but are these applications being granted? Some of you might be aware that AI-related patent applications can face additional challenges compared to other types of invention. Chris is going to talk to you about that later. And discuss how the European Patent Office assesses patentability of AI patent applications. But before I hand over to Chris, let's take a look at whether AI-related patents are indeed being granted. Conor Crickmore is one of our trainee patent attorneys. He's done some research to look at this aspect. His data shows that the number of European patent applications and UK patent applications being filed for AI-related inventions, shown by the orange line in both these graphs, follows the trend that we saw earlier for the WIPO figures. Very roughly speaking, around a half of European patent applications and UK patent applications are granted. It takes about 3 to 5 years on average for a European or UK patent application to be examined, and a conclusion reached by the relative office as to whether to grant the patent application or refuse the application. So we'd expect that the number of granted AI patents should also be on the increase, with the number of patents granted being roughly 50% of the number of patent applications, delayed by around 3 to 5 years to accommodate the delay between filing and grant. And this is what we see in Conor's graph. This grey line in the graph indicates the number of granted AI-related patents by year. So I think from our research, the good news is that despite any difficulties AI-related patent applications may face, during the patenting process, they are being granted for AI-related inventions. As I've alluded to, it's not all plain sailing as far as AI-related patents are concerned, and they can face additional challenges. So I'll hand you over to my colleague, Chris, who will discuss this in a bit more detail. Over to you, Chris.
Thanks, Julie. Can I get the next slide? Yeah. So AI inventions are more difficult to patent than average inventions, but they're not hugely more difficult. And if we know what issues we might face, then we can prepare for them in advance, like when a patent application is being drafted. And we can take steps to ease the way later in prosecution. So I'm going to talk about some of the issues we face with applications for AI inventions and how we can address them. So, like any other patent application, a patent application for an AI invention has to meet the usual requirements compared with the prior art. I'm talking about novelty and inventive step. But in nearly all jurisdictions, they also have to overcome a further obstacle, that's excluded subject matter, by which I mean subject matter that is excluded from patentability by law. And I'm going to give a brief discussion of how this works in Europe. So Julie gave an overview of AI earlier and showed how it involves a mathematical processing of input data to get an output. Taken in isolation, it's basically a mathematical method. And the thing about mathematical methods is, while they're a lot of work, they can, in theory, be done mentally or with pen and paper. And in Europe, mathematical methods are one of the categories of excluded subject matter. So inventions that relate merely to mathematical methods are not patentable. So if we want to patent an AI invention, we want to show that the invention is not merely a mathematical method. And in Europe, this is tested in a two-step process. In the first step of the test, the claim as a whole is checked to see if the whole thing is just a mathematical method. And if it is, then the claim is not patentable. In the second step, which is only taken if the claim passes the first step, the claim features are separately assessed to see if they themselves are excluded subject matter. So we will be looking at, for an AI invention, is a claim feature by itself merely a mathematical method? And if it is, then it might be ignored for the assessment of inventive step. And I'll expand on this more in a minute. And finally, patent applications have to meet sufficiency of disclosure requirements. This goes for all patent applications. The skilled reader has to be able to implement the invention based on the content of the application. Now, this includes implementing the AI component of the invention. And I'll come on to that in a minute as well. Next slide, Julie. Thank you. So the second step of the test I mentioned is considering each feature of the claim to see if that feature relates to excluded subject matter. If it does, then it might be ignored for the inventive step assessment. But it could still be counted in the assessment of inventive step. And there are two ways that we can show this in Europe. So firstly, if that claim feature contributes to the technical solution of a technical problem, in other words, if that feature is more than just a mathematical method, then that feature can be counted. And that word technical is important here. It doesn't have a precise meaning in European patent law, by design, I think, to allow courts to sort of change their mind on things and allow for developments. But essentially, this word technical means can be viewed as sort of not any of the categories of excluded subject matter, such as mathematical methods. So there are two ways we can show that this mathematical method, AI claim feature, contributes to the technical solution of a technical problem. The first way is if we can show that this AI claim feature takes into account the internal functioning of the computer. So perhaps there's an interaction between the AI mathematical steps and the underlying computer components. Perhaps the AI is designed around the memory or processor limitations. Perhaps it reacts differently according to those limitations. That can cause an improvement in the computer itself when running the artificial intelligence. The other way is if the AI claim feature is applied to a different field that is beyond the mathematical method itself. So perhaps the AI controls a machine, and the effect of the AI is that the machine behaves differently. And so there is now an effect in the real physical world, which is an effect beyond the mathematics of the AI. That can be shown to be this technical solution to a technical problem. Next slide, please. Thank you. So I'm going to go through some hypothetical examples that show the assessment of excluded subject matter and inventive step and how they interplay, how they work together, and how the different stages bite in the assessment of compliance with these excluded subject matter rules, and how they can be overcome. So this is a first example, and this is really basic. And I say, never mind whether this is new relative to the prior art. We're just looking at whether the excluded subject matter rules bite and at which stage in the analysis they do. So in this case, the method specifies the use of a neural network, an artificial intelligence, to output a number based on calculations. And this method is entirely a mathematical method. So it's at the first hurdle, this is excluded from patentability. The analysis just stops here. We don't even get on to looking at novelty and inventive step. Next slide. So here's another example, and this claim has a little bit more. This claim specifies that the method is implemented using a computer. Now, this is quite a big change in the assessment, but it doesn't actually change the final result of the analysis. So now the claim as a whole is not merely a mathematical method because it's implemented on a computer. There's something here more than just mathematics. So we clear the first hurdle, we move on to the next stage, inventive step. So now we look at whether the AI features contribute to a technical solution to a technical problem. And well, they don't in this case. The AI features are exactly the same, and the output of a number based on calculations doesn't really give anything beyond the mathematics, never mind the fact it was performed using a computer. So now the AI claim feature, this use of a neural network, is ignored for the assessment of inventive step. So when we do assess inventive step, all we're left with is a method using a computer, which is, of course, well known. And so even though this claim clears the first hurdle, it wouldn't pass the inventive step test. So it still wouldn't be patentable in Europe. So while it's easy to overcome that first hurdle with a perhaps somewhat trivial amendment here, it doesn't really help with patentability. Next slide. So here's another example, and this claim includes even more. In addition to being performed on a computer, the AI claim feature takes into account the functioning of the underlying computer. This means that the AI claim feature, the neural network, has a technical contribution to the operation of the computer. It means that the AI claim feature can be counted in the assessment of inventive step. So inventive step would be assessed in this case on the basis of whether the complete combination of features is known or obvious in view of the prior art. And we're now in the same position as any invention that isn't AI. So to quickly jump on Tessa's question there, a neural network is one of the main types of artificial intelligence. It's just the mathematical arrangement of mini computational blocks that to simulate the nerve cells in the brain. Yeah.
Okay. Sorry, I'm a biologist, so so I'm here to learn.
Yeah.
So a neural network in the sense of a human being or an animal, I understand what that is. I don't know why do you call the artificial intelligence element a neural network?
Because it's a network of individual sort of functional blocks, mathematical blocks that simulate the operation of a neuron. There could be hundreds of them, thousands of them, all connected to multiple other neurons, and they're simplified, but they're designed to work a bit like a neuron. There'll be weighted inputs, and the strength of those inputs are then combined, tested with a threshold perhaps, and depending on the outcome, the result of a comparison, they will be passed on to further neurons.
So that's how everyone calls it, a neural network.
Yeah, that's just there are other ways of implementing an artificial intelligence that don't use neural networks, but that's the standard way.
Okay. Thank you.
That's fine. Yeah, so in this case, we do proceed to a full inventive step assessment. We take into account the AI, the neural network feature, in the assessment of inventive step, and we're in the same position as any other invention now. We've cleared the excluded subject matter problems entirely. Next slide, please. And here's a final example. And as before, the claimed method is implemented using a computer. So the first hurdle is cleared automatically. And in this case, the output of the AI claim feature is applied to control a machine. The machine behaves differently because of the AI claim feature. And so the invention as a whole, in this case, is not really just a mathematical method. The invention is really a way of controlling a machine that just so happens to make use of a mathematical method. So inventive step is again assessed for the complete combination of features. And again, we're now in the same position as any other invention that isn't AI. Next slide. So from the way excluded subject matter is assessed in Europe, it helps us to actually divide AI inventions into two types because of the different issues they face. So firstly, there is the fundamental AI invention. And by this, I mean an invention that relates to the mathematical method itself. So we're talking about an improvement in the mathematical algorithm. These are the sort of inventions usually created by mathematicians, computer scientists. And secondly, there's an applied AI invention where the AI is used as a tool to solve a problem. Next slide. So I'm going to talk quickly about fundamental AI inventions. Now, this type of AI invention isn't really the focus of our talk, so I will try and be brief on this. But if the invention is the AI itself, the mathematical method, we would ideally like to patent the AI itself, and we wouldn't want to be limited to a use of that AI to solve a particular problem. That would give the broadest coverage, and that would make the patent the most valuable. But in Europe, we have to look at whether the AI invention takes into account the internal functioning of the computer. Is the AI, the mathematics of the AI, specifically adapted based on memory limitations or how the processor operates? Does the AI do something different based on the properties of the computer on which it's run? And if not, then the AI features are not counted in the inventive step assessment. And this is quite a big deal. You can come up with an ingenious new mathematical method, and if it doesn't take into account the internal functioning of the computer, then you won't get a patent for it in Europe or for it by itself in Europe. Of course, at the time of drafting and filing a new application, we might know that the invention is the AI itself, but we don't know if we're going to be able to persuade the European Patent Office that it takes into account the internal functioning of the computer. And I think this means that that applicants for fundamental AI inventions, they ought to have a fallback position in case their arguments on the internal functioning of the computer are not successful. So applicants should be prepared, if necessary, to have to limit their invention to the use of the AI in a particular field. But we're not allowed to add new matter to a patent application once it's filed. So this means we have to think about the uses of the AI, applying the AI before the patent application is filed. Now, a specified use of the AI doesn't have to be a very narrow technical field. And I think applicants might be able to get away with specifying a whole list of different uses of the AI. And with this, if the main uses, the main commercially important uses of the AI are covered, then the applicant might get useful commercial protection. Next slide. So I'm now going to focus on the application of the AI to a technical field, an applied AI invention. And we come back to that question of what does technical mean. And I said a few minutes ago that this term is a bit vague. It's imprecise. But one way of looking at it is, does the AI claim feature have any effect on physical reality? If it does, then we're normally good. Another way of looking at it is, does the AI claim feature have any effect beyond the data stored on the computer? One obvious example of a different field is mechanical engineering. If an autonomous vehicle behaves differently because of the claimed AI feature, then that AI feature has helped solve some problem in the technical field of vehicles or autonomous vehicles. And I chose that example because I think it's clearly on the right side of technical. It's away for these sort of mathematical methods or the abstract concepts. But this technical term is actually much broader than that. It covers most traditional technology. And actually, there are some fields that are accepted to be technical, even if the result of the AI claim feature doesn't go beyond data stored on a computer. One example I've given here is image processing. So all the operations we can do on our smartphones to enhance images, this is accepted by the European Patent Office to be a technical field. The rationale, I think, is that this represents some of the techniques that were historically performed by photographers in dark rooms, and whether the image is represented by electricity stored in a computer memory or whether it's a physical image should be immaterial. That's their reasoning anyway. So this means that in many or most cases, an invention that involves the application of AI will overcome excluded subject matter issues and allow an assessment of inventive step of all of the claim features in combination. Now, this doesn't get us over the line, of course, because this just means that the claim is assessed properly for inventive step. It doesn't mean that the assessment will find that there is an inventive step. And this means that the applied AI invention has to be non-obvious. And where we are right now is that AI has been hyped quite heavily, particularly in the last few years. There have been many articles written and published suggesting that AI is going to transform every single industry. So where we are now in 2021, I think it would be difficult to persuade a patent examiner that it would not be obvious to consider the use of AI in probably any field. So a patent claim that is different from the prior art only in that it mentions using AI in a non-specific way will be difficult to patent in Europe, and I think probably anywhere. So to get a patent for an AI application, in Europe at least, we will probably have to go beyond this, and a patent claim will have to include more application-specific details that would not be obvious. And to give you an idea of what this means, I'm going to show a couple of examples of patents that have been granted in Europe for AI applications. Yeah, thanks, Julie. So I put an example up on the screen here. This patent is for a gas turbine engine that uses AI to control the operation of the engine. And I've paraphrased claim 1 here and simplified it to emphasize the AI elements. And the claim is an aircraft engine comprising a controller that controls the engine. The controller is adjusted in response to a neural network, and the neural network is trained on a baseline profile applicable to multiple engines and is further trained on in-flight aircraft data for that particular engine. Now, I've highlighted in red that what I think are the AI steps. And the invention here is the use of 2 different training stages. A first stage that trains the AI on a generic engine profile to control a generic engine, and a second stage that represents continually training the AI for the specific engine based on data for that specific engine. And perhaps this might seem simple, but it was enough in this case to be considered non-obvious for the skilled person working in the field of aircraft engines. Next slide. This is another example, and this one concerns image processing for images obtained in a medical application. And it's a method for denoising. So we mean removing noise from medical images in a computed tomography or CT system. The method comprising scanning a patient to get CT image data and then denoising the CT image data by applying a deep learned, so this is the AI here, or deep learning, a deep learned multi-scale network of filters that include a cascade of trained AI denoising filters at different resolutions that are configured based on a combination of CT pixel data and metadata of the CT system. So we have this large amount of data is taken from the scan of a patient, and we have this lots of different individual artificial intelligence filters for processing this 3D data at lots of different resolutions. And these operate according to AI, and they're configured based on pixel data and metadata. And then we have a final step of displaying an image rendered from this data. So here, the non-obvious application of AI seems to be the use of these multiple different filters at different resolutions, where the filters are configured or trained in the AI sense, based on the combination of pixel data from the images and metadata of the imaging system. And this is quite similar to the previous example, where we've got a sort of device-specific training going on here. I'll come back to Toby's question in a minute, if that's okay. And that was considered enough. So for inventors working in these fields, it shouldn't be too difficult to show a non-obvious application of AI. I don't think it's an insurmountable hurdle. And I think just as an aside on this case, the final step there is this display of a denoised image. And this display is a real-world physical effect, but it might not be necessary. If you remember, I said a few minutes ago that image processing is accepted to be technical. Denoising the CT data might be a technical end in itself. And perhaps that would be a more valuable patent if it didn't require the method performed by a single party to display the image data. If it didn't have this limitation, it might allow an splitting operations between different parties, perhaps in different countries, perhaps with cloud computing, to be caught by the patent. But we don't know, in this case, we don't know what the applicant wanted to cover. Next slide, please. So sufficiency, this is a new issue and it's an old issue. Sufficiency has always been a requirement for a patent, but a recent EPO appeal decision has highlighted sufficiency as another risk for AI inventions. And in this appeal decision, the patent application was refused for insufficient disclosure, and the skilled reader couldn't implement the AI invention based on the disclosure in the application. The invention was the use of blood pressure measured at a patient's periphery, we're talking blood pressure measured at, say, the skin, to determine blood pressure at the heart or the aorta. And this is done by an AI processing data measured from the periphery, where it's relatively easy to measure blood pressure, and the AI outputting the blood pressure at the aorta, where it's relatively hard to measure pressure. And the patent application didn't disclose how to obtain an AI that performed this function. The application mentioned training, but only in passing, and not how the AI is trained or what the data was used to train the AI. And the EPO Board of Appeal said that the skilled person is unable to implement the invention based on the disclosure in the patent. Why this happened, I don't know. Maybe the applicant thought that the implementation was obvious once the result was explained, and perhaps it was. I sympathise a little bit here. I don't think what they needed was much more than they had. Maybe all they needed was a few sentences, and they might have got away with just saying they trained it on physical measurements of blood pressure taken at different locations in patients' bodies, including the periphery and the aorta. Perhaps that would have been enough. So how do we meet the sufficiency requirements? Saying nothing at all is probably not a good idea following this decision. One way we could try is to give details of the data set that's used to train the AI. It probably doesn't need to be that much. We probably don't need to include in the patent application all of the data used to train the AI. An explanation of how to obtain the data or how to obtain a set of data that would do the trick could be enough. Another way is to provide an implementation of the trained AI itself within the patent application. Perhaps a table of thousands of numerical values that represent all the learned parameters of the AI. And, well, depending on the amount of data, this is probably not going to be practical to include in the application itself, certainly for complicated applications. But I know that life sciences patents can make use of sequence listings, and I sort of wonder in the future, could we see something like this become available for AI inventions? Is there even a way to hack the sequence listing system currently and include other data in that? I don't know, but maybe in the future, but not yet. But one thing to emphasize is that under disclosure in an application isn't fixable later. So we need to err on the side of over disclosure to avoid this becoming a problem. On the other hand, I'll just say that I don't think this spells the end of speculative applications in this field. I can imagine someone filing a first priority application with a very thin description of the AI, following up with a later application claiming priority that has more details once the inventors have worked them out. I think you wouldn't have to rely on that priority application, but you're probably better off with it filed and having the option to argue for priority later than if you didn't file at all, if you waited until everything was solved and planned out. Next slide. So given that we know some of the issues we could face when trying to patent an AI invention in Europe, there are some things we can do before filing to improve our chances. So just remember that the European Patent Office is really strict on added subject matter. So it's even more important that we try to address this before we file. So the first point is to be aware of these excluded subject matter considerations. Perhaps give some thought to which of the two exceptions do we intend to use to have the AI claim features counted for inventive step. Internal functioning of the computer, application to a technical field. This will depend on whether we think we have a fundamental AI invention or an applied AI invention. But either way, we should describe how and why the invention takes into account the computer and what effect this has. Even if we have a fundamental AI invention, we should probably be thinking of possible fallback positions of applications or uses of the AI. The next up is sufficiency of disclosure. As I said, this has only recently emerged as an issue for AI inventions, but for now, I think the best way to preempt possible objections is to explain how the AI is trained. How do you end up with an AI that can provide this desired functionality? I think the important thing here is to just give enough information that the reader could identify or generate a data set that could plausibly be used to train an AI to have this desired effect. Whether we have enough or not is difficult to judge, but for anyone drafting these applications, I think maybe we need to think about whether we could implement the invention. Probably not. But do we have enough information that we could sort of tell a story about how it might work? And this isn't always possible, we should get inventor input when we can. Could the inventor or one of his colleagues implement the invention based solely on the disclosure in the application? If the inventor has to make any leaps of ingenuity to actually implement the invention, we should explain those leaps in the application. And the final thing, and this is something I haven't really discussed, but it's that for inventive step, it's often helpful to show some results, some experimental results. It shows that the AI can be trained to have this desired functionality, which this isn't always appropriate, and it's going to depend, case by case basis, really. But it's worth giving some thought to how can we prove to a skeptical patent office examiner that the invention is particularly beneficial. So what I've just been talking about can be seen as a bit of a checklist to reduce the chance of things derailing in prosecution. And I've given a particular focus on what happens in Europe, but I don't think any of these points will make it any harder to get AI patents in other jurisdictions. And in fact, I think they'll help elsewhere too. Sufficiency of disclosure is a possible problem everywhere, and inventive step too. In some countries, such as Japan, it's even more important to have evidence that the invention works and provides some advantage. Otherwise, the JPO just decides that there's no inventive step. Anyway, I think if we follow some of these tips, we can avoid the risk of applications for AI patents being refused. Anyway, I'm going to hand you back to Julie.
Thanks, Chris. So we're just about to sort of sum up and come to a finish, but there's just a few other topics that often come up when we discuss AI and that are often discussed. Chris mentioned sufficiency with respect to training data, but as discussed, all machine learning artificial intelligences have a training step. What we do see, though, is that the training step is not necessarily performed by the same party that uses the trained AI. And this can create issues if you have to include training steps in the claims of an AI implemented invention. In in our department in electrical, electronic and software, we're used to looking at this sort of issue because it's very frequent that when you're considering distributed processing between operations that run, say, partially on a server system and partially on a client system, you have aspects of the invention running being performed by one party and other aspects by another. And so it's something that we would consider when assessing whether to file a patent application and how to claim the invention. We are seeing increasingly companies seeking AI support. For example, there's lots of pharma companies linking with AI companies. We've seen AstraZeneca partnering with Benevolent AI, Bayer partnering with Alliance for Artificial Intelligence in Healthcare, and for example, Sensign Health, and Novartis with Benevolent AI, Intel and others. And we're very much expecting that this level of collaboration will extend to other fields and continue to grow as AI is adopted ever more widely. Where should you apply if you're thinking of an AI-related patent application? There are different approaches in patenting of AI-related inventions in different countries. I took a straw poll of our electronic department on how people viewed it as how easy it was to get an AI-related invention patented in different countries. Our view is very much that AI-related patent applications are most likely to progress in China, Japan, and Korea. But with the proviso that in China, for example, method claims are difficult to enforce, and this can make it difficult to get adequate patent protection for any computer-implemented invention, including, for example, artificial intelligence-related inventions. Next up would be the US. This might be a surprise to some, given the US stance on refusing applications which appear to relate to abstract ideas. But the US Patent Office seems to view AI-related applications very favorably. It has a relatively high grant rate anyway, but its grant rate for AI-related inventions is probably above its general grant rate. And if you file a patent application only in the US, you can avoid publication of your application until it's allowed. So you can sort of have your cake and eat it. You can apply for patent protection, and only if the patent's granted do you have to disclose to the world how your invention can be reduced to practice. Again, there are some other issues. There's ongoing debate as to whether the US courts will actually apply the same standards in patent litigation that the US Patent Office apply when deciding whether to grant an AI patent. So it's a bit of a watch this space. The European Patent Office is seen as tougher on AI-related patent applications, but we've seen that large number of AI-related inventions are being filed, and that with the surge in filings, we are seeing an increase in the number of patents in this field being granted. The current indications are all that this will continue. It's usually considered harder to get a patent for sort of core AI, that's the algorithms that underpin the computer, that predicts the outcome from the data, than for applications of AI to a problem in a technological field, such as an AI applied to an autonomous vehicle, for example, or AI applied to looking at imaging of clinical medical slides. The European Patent Office guidelines particularly direct that image processing is patentable subject matter. And so I've certainly seen several AI medical image processing cases get what I consider to be an extremely easy ride through the examination process to grant at the EPO. We would say that UK patent applications are probably one of the hardest to progress. Generally speaking, we would see that computer implemented inventions are more difficult to progress in the UK than through the EPO, for example, and artificial intelligence is just falls within that broader computer implemented invention field. And so the situation there's the same. The UK IPO has a bit of a reputation for refusing to search patent applications on the grounds they're directed to excluded subject matter when they're related to AI inventions. And our experience is that it's really difficult to overcome this sort of objection once it's been raised. So that's sort of discussing where you could or should apply. Another issue that's often in the media is AI inventorship. can an AI invent? I would say in intellectual property terms, my view is that it can't yet. I see that AI is more limited to performing the function for which it's designed, requiring both suitable design and a human to give it purpose or direction. And I don't think that in those circumstances, you could truly say that the AI did the inventing. There's at least a human inventor using the AI. I have seen examples of what I think is AI designing something. A chair that looks like an avocado springs to mind, or certainly composing music in the style of another musician. But neither are what I would think of in intellectual property terms as an invention, a technical solution to a problem. Some of the reason for the press interest is patent applications were filed in the name of an AI, the so-called DABUS cases. It raised the profile of patents, and maybe that was its purpose. But the EPO rejected the application on the grounds that the requirement is to name an inventor, and that means a human inventor. And the IP5 I referred to earlier, the US, China, Korea, Japan, and the European patent offices all recently confirmed in a joint report that an inventor of a patent has to be a human being. So from my perspective as a patent attorney, the issue is currently moot. But that said, several patent offices are consulting on and considering whether they need to change the rules relating to inventorship to future-proof them. Another commonly debated topic is whether AI will change the way that inventive step is assessed and the bar that is seen to whether or not an invention is patentable. Some people even go as far as to say that there should be a dual system with a higher inventive step bar for AI-derived inventions and a lower bar for more standard, say, pharma approach with researchers working in labs. My view is this is unworkable and unnecessary, but it's an area certainly of ongoing policy consideration. AI is another tool that researchers can use, and we wouldn't make a distinction between using a traditional computer program and doing the mathematics manually. And I think we shouldn't make a distinction between using an established AI tool and a more traditional research team-based approach. So that sort of brings us to a close.